Hey guys, welcome to the first unit and lesson video for AP Physics 1 Kinematics. Before we begin, there is a disclaimer. Materials here will differ from regular grade physics, so previous physics knowledge is required. However, kinematics is the basis for all physics, so there will not be any pure AP concepts in this video. We simply ask you to have an understanding of scalars and vectors in regards to position. Before we begin, I'm sure you want to know who we are. My name's Alex, and this is Esser. We are working with PrepB to create this series of AP Physics videos. Today, we will be going through uniform motion, uniform accelerated motion, and finally, projectiles. Esser has created simple practice problems, and I will walk you through some problems from AP College Board themselves. Here we go. Uniform motion. The concepts introduced here are velocity, displacement, and time. Note that we use metric measurements. The general formula that relates to these concepts is V equals d over t. What does that mean? Well, V stands for speed, d is distance, and t is time. The subscript AVG stands for average, and the delta symbol stands for change. We can see that change means the initial value subtracted from the final. We usually simplify the look of the equation and just write it as V equals dt. Here's our first practice problem. I highly recommend that you pause the video right now and see if you can solve it, or at least make sense of it. Okay, let's get on with it. A good strategy to have when solving any physics problem is to first write down the known variables and relate them to the equation. The question tells us the distance, 0.75 meters. The change in time would be 3.25 seconds minus 2 seconds, which give us 1.25 seconds. Sub that in, and it turns out the average velocity is 0.6 meters per second. Let's move on to uniform accelerated motion. We're taking the concepts learned from uniform motion and adding the factors of acceleration and gravity. Here we have 9.81 meters per second squared as acceleration due to gravity, but 10 meters per second squared is also accepted. Just like the average speed equation, the equation for average acceleration depends on change values and is abbreviated as A equals V over t. We don't just stop there with equations. Here are 3 more commonly used equations involving the concepts learned. I and F stand for initial and final. However, some people prefer to use different symbols. All are accepted as long as you define your variables. Let's head on to the problem. Again, pause the video and take time to understand the question. Alright, here we go. We know the speed, time, and acceleration. This formula uses these 3 to solve for the change in distance. So we plug it in, simplify, and the answer turns to be 6.5 meters. The last section of kinematics is projectile motion. This is where vectors are introduced. Most often we imagine a ball that is being kicked into the air. We know that the ball travels in an arc shape, and in this scenario, gravity acts upon the ball, but air friction is negligible. What we are solving here are instantaneous points, not average numbers. Vectors are your directions, and trigonometry helps us define these directions. Here we have initial velocity, horizontal distance, and vertical distance in the shape of a right triangle. Notice how the triangle only takes up half of the motion. That's because the first half of the motion and second half of the motion are identical. What goes up must come down. We use trigonomic ratios, sine, cosine, and tangent, to figure out our unknown values. Projectile problems take longer to do when compared with the first 2 sections, so for the sake of speed and simplicity, here is a video where I walk through a College Board AP projectile problem. The video is 10 minutes long, but I've tried to make it as enjoyable as possible. That wraps up everything for this video. If you have any questions, please contact me or Esser on Instagram, and we'll be more than happy to help you out. Thanks, and have a great day.